Okay, thank you everybody for coming today. I'd like to take a minute to introduce David and then turn it over to him for his presentation. It's a real honor to have David here today presenting. I had the very good fortune of being able to interview David with a colleague of mine, Lasse Gerrits, for a book we're writing. And I always find David endlessly intriguing and just very good at getting me to think, even when I think that I already know something that I'm talking about. So it's that pleasure that I'm looking forward today. David has a number of different roles. Presently, he is the founder and chief scientific officer of Cognitive Edge, and also founder and director of the Center of Applied Complexity at the University of Wales. David does a lot of keynote speaking, and this is a real privilege to listen today. I think one of the things that distinguishes David is both having a trajectory and history in systems thinking, and then seeing that evolve more recently into complexity and trying to figure out or sort out what that means for organizations and for the work people do in everyday life. For those of you who are not aware of CECAN, CECAN stands for the Center for the Evaluation of Complexity Across the Nexus. Nigel Gilbert is the lead for this project, University of Surrey. Myself as one of the co-Is and on the steering board. And we have had as a focus for the last several years, developing methods and tools for the evaluation of complexity within public sector, private sector, and third sector. And this has been part of the series of presentations that we've been doing for the past few years. And again, very, very excited to have David here. And with that, I'll turn it over to you.
Okay, so I can't actually see anybody, which is always a disaster on this. Brian and I were talking about that earlier, but so I'm going to talk for 45 minutes and hope to God I'm making a connection with people. The Q&A section is open for people. Please use the Q&A, not the comments. And I will actually have that open and I'll be monitoring that as we go. Yeah. My colleague Beth Smith is also on the call as well. So you've got two of us. Yeah, if you need to do follow through or chat with any of us. So my goal on this is to give you a sort of general background to the approach we're adopting. Then specifically as requested, talk about the Cynefin framework and then move on to the latest framework I'm working on called the Esterine framework, which I'm getting really excited about, which is actually taking constructor theory from physics and using that to extend the EU field guide. Yeah. So I'll do a sort of general introduction, then move into the two frameworks and open up for questions. So the general name for the field I work in is naturalizing sense making. It's acknowledged in the literature as one of the 5 distinct schools of sense making. The others are people like Brenda Dervin, Gary Klein, both of them were good friends. Carl Weick, who won't speak to anybody else, but I'm sure we would be friendly if he ever got to talk with us. And a whole body of guys in IT. So this is one of 5 distinct schools. And I'm defining sense making with a hyphen. This matters. With a hyphen, it's a verb. Without a hyphen, it's a noun. And sense making for me is how do we make sense of the world so that we can act in it? And with that comes a strong concept of sufficiency. I never know everything that I need to know in order to act, but what sort of actions can I take based on what I currently know? And that's both individual and collective. So that's the meaning of sense making. Naturalizing, this comes from philosophy. And my background, by the way, is philosophy and physics as a joint honours, which means I have a physicist's despair of social scientists because they never have enough data to form any conclusion of any relevance anyway. And we won't talk about philosophers' attitude to them. But you'll see that come through as I sort of run through this material. Naturalizing in philosophy means to base what you do in the natural sciences. And so one of the distinct aspects to our approach is to use natural sciences as what in complexity theory is called an enabling constraint. So nobody is to try and pretend that you can treat a human system with all of its variables and all of its complexity in a sort of scientific manner, in the manner of science in the 19th century. That isn't going to work. But there are things we know in science that we can use as constraints, and then we can build methods compatibly with those. And This is a very practice-oriented thing. It's theory informing practice. So I'll give you a couple of examples of that and then go on to the implications. So the one I always quote, and it's some of you will have heard this before, but it's worth mentioning. And this is a famous set of experiments done with radiologists. So if you give radiologists a batch of X-rays and ask them to look for anomalies, and on the final X-ray, you put a picture of a gorilla, which is 48 times the size of a cancer nodule. On average, 83% of radiologists will not see it, even though their eyes physically scan it. And the 17% who do see it come to believe they were wrong when they talk with the 83% who didn't. This is called inattentional blindness. It's part of what we are to be human. You can't actually train people away from it. And one of the reasons is the most we scan of available data is about 3 to 5%. That triggers a series of memories, both cognitive, physical, and social through common stories. And we blend those fragmented memories together and we do a first fit pattern match, not a best fit pattern match. We satisfy, we don't optimize, to reference another body of literature. Now, in evolutionary terms, you can see why this happens. If you think about the early hominoids on the savannas of Africa, something large and yellow with very sharp teeth runs towards you at high speed. Do you want to autistically scan all available data, look up a catalogue of the flora and fauna of the African veldt, and having identified lion, look at best practice case studies on how to avoid lions? By that time, the only document of any use to you would be the book of Jonah from the Old Testament, which is the only known example of an escape manual from the digestive tract of a large carnivore, written by a survivor. So we evolved to make decisions very, very quickly based on a partial data scan, privileged in our most recent individual and importantly collective experiences. Now, I say that's something, and it's interesting, Klein, myself, and others now basically say there's no such thing as a cognitive bias. There are only cognitive heuristics, because what we call biases have actually evolved over the centuries, and they have actually huge pragmatic value for humans, because in the round, they reduce energy consumption, which is what evolution is all about. Some of you will start to realize by now that I'm challenging the Enlightenment assumptions that characterize Northern European and North American society. If you just give people the right information and the right training, and they have the right attitude or the right mindset, they're still going to make the right decisions, because they will only see data they're expecting to see. And the rare individuals who see something they don't, then have a problem. So our work, for example, can I reference in the EU field guide now, is we'll use the whole of a workforce, or we're now starting to build the whole of a citizenship as a human sensor network, which can interpret data in real time, and from which we can see multiple patterns, which gives us an evidence-based under uncertainty, but also from which we can see outliers. And I'm going to show you an example of that later. It's the work we've done on Kaufman's work on fitness landscapes. And we're currently building this with one of the big farmers. So basically all of their employees will be effectively continuously able to assess the situation based on what's called high abstraction metadata. So it's not gameable. And so the executive can literally use the whole of their workforce to assess the situation in real time, identify the feasible and the unfeasible ways forward, and also to find the 17%, the outliers. And we've done similar projects in South Wales on citizen engagement, and in Malmo on understanding refugees. So this concept of human sensor network, which actually has cognitive, cultural, and experiential and cognitive diversity built into it, and looking at things from multiple perspectives in real time, is the key sort of pragmatic approach which comes out of this. Yeah, but I say hold that one for the moment. It's called inattentional blindness. Yeah. The other one is this, and it links into the same thing. And I said recently on Twitter, and it really irritated some people, but unfortunately it was the right people. If I irritate the right people, I feel good about it. When I pointed out that there, these common phrases of mindset, or worse still, mental models, just a really bad science. I mean, I know Peter Senge has it in the book, and it was a cute concept when it came out in the 70s or 80s, but we know it isn't like that. And one of the reasons is we're now in a post-Cartesian understanding of consciousness, in that we know that consciousness is this distributed function of the brain, the body, and its social engagements. And the concept of a mental model is really that sort of period in the 80s and 90s where people were swept up in computers and thought that human beings, and I quote unquote here, were a limited capacity information processing device. Yeah, the reality is human decision is hugely complex, is very significantly social, and I'll come on to that in a minute. It's not an individual choice or an individual decision. There aren't any mental models, and there's no such thing as a mindset. Mindset is a great way, by the way. I ran this massive change program. It was absolutely wonderful. And you bastards didn't make it work, so you didn't have the right mindset. So there's this sort of blame allocation, which goes with that in terms of the way it works. So post-Cartesian models of consciousness are important to understand. And then we move into complexity science. As Brian said, when I started this work, I worked with Frank Land on the LSE pod, some of the early work on systems dynamics. I worked a lot with Peter Cheklin's stuff on soft systems and was interested in cybernetics. But I think I mean, several things come out of this. One is I want to say I respect that tradition, but I don't think it scales. And so this issue about scaling for me is really important. Most interventions based on that involve workshops where people come together and agree to think holistically and engage people. And, you know, it's all good stuff, but the issue is how do we scale that out, yeah, in terms of the way it works. The other big issue is I started to realize as I increasingly got into complexity science, and remember the roots of complexity science are very different. They come from biology and chemistry and to some degree physics, whereas systems thinking comes from information science and from Shannon. They intersect from time to time, but those backgrounds are actually very significant in terms of understanding why they're the same or why they're different. And one of the other things, and I'm quoting Gerald Midgley, who's a good friend and a colleague at Hull University, who says one of the ways you know a system is because it has boundaries. Well, from a complexity point of view, many systems actually don't have boundaries. They're just disparate. Yeah. So we're starting to understand more of the science of this stuff. And I think what systems thinking did in the 70s, 80s was rather like the fact that human beings could build canals because they understood gravity in practice. But then Newton came along and we had the science. And once we had the science, we could do more scaling. So complexity science, to me, is really important. It deals with systems, this is quoting Giraro, which have no material linear causality. So the key thing to understand about a complex adaptive system is the same thing will only happen again the same way twice by accident. It's not inherent in the system. You can't predict the qualities of the whole from the part. I mean, one of the really things which irritates the hell out of me on social media at the moment is people talk about quantum entanglement and quantum predictability, and they just haven't realized, you know, if I'm dealing with at the quantum layer, I've got basically, you know, things working in combinations of threes, quarks. So the number of possible combinations is very low. The minute I move into a biological entity, the sheer number of complications of connections has become exponential. Yeah, and you can't go from the particle to the whole. There's a free will argument in here if anybody wants to get into it. So basically, the properties of a system are different from the properties of its parts, and at a very, very significant level. The only thing I can say with absolute certainty about a complex adaptive system is that whatever you do, if you intervene, will have unintended consequences. And we're now actually arguing at a government level, that means that you are actually ethically responsible for them. So you know it's a complex system, you've done an intervention, you know there will be unintended consequences. You have to be ready for those because, as I say, that's one of the few certainties. So the thing we know about a complex adaptive system is that it has propensities and it has dispositions. I'll come back to constraints at the end of this. So dispositions, I can say that the system is currently disposed so that this type of behavior is more probable or plausible than these types of behavior. But I can't actually predict that. I can just make statements about the dispositional state. I can also say that aspects of the system have propensities, so they have predictability. This is in Popper's sense of the word. So a system has dispositions and it has propensities. And it's also critically got modulators. So I'll give the metaphor I use a lot for this. If you think about, you know, I've got a flat surface. And around the flat surface, I have electromagnets. You can tell my background here, this is going to be physics, which can change in polarity and strength. Some of them I control, some of them have been controlled by people I know. Some I've got no idea whether they've been controlled or not, but they're actually changing. And in the middle of the table, which has a high coefficient of resistance for anybody who wants to get pedantic with me, yeah, there are cast iron discs, some of which are standalone, some are connected by elastic bands, some by chains. Now, if all of the magnets keep the same polarity and the same strength, I can predict what will happen to the dispositional state of the iron units, the sort of hockey puck type things. If I change one of the magnets, I can predict what will happen. If I change two of the magnets, I can predict what will happen. If I change three of the magnets, I can no longer predict it. Right? And in complexity, those magnets are called modulators. So, but interesting, if you think about it, the more of the modulators I can directly influence, and provided I've got real-time feedback from the system as a whole, I can manipulate the modulators to achieve the sort of solutions I want. And the more modulators I control, the more secure I am in what I do. Now, this is a big flip for people, particularly in government policy, because what you're basically saying is the most important thing is to understand the present state, understand what the modulators are, how many of the modulators you can control, and then create real-time dynamic feedback. And I do mean real-time, so you can see patterns emerging, yeah, within that system. Now, I could go on to, I could go on and talk about material engagement theory. There's a whole, the way that artifacts change human cognition, the work we're doing in epigenetics. We now know the mechanism by which culture inherits across 2 generations. So there's a whole body of science gone into that, but those are the ones I really want to rely on in the rest of the lecture. And our whole approach here is to say, what does the theory say? We then develop methods or tools consistent with the theory. Then we practice those methods and we modify them accordingly. So it's actually much more like physics, if you think about it. Theoretical physics does the maths, applied physics tests the mathematics, and we're sort of in that mode. What we're not doing is a so-called empirical approach. So we're not taking cases, go and study 10 or 15 cases and from that derive general practice. And there are several reasons for that. One is the gross confusion of correlation with causation. If you go and study 15 organizations who are deemed to be successful, you identify things they have in common, and you say, do these things, then you too will be successful. That's the sort of basis of virtually every article in the Harvard Business Review and every Big 6 consultancy method. Yeah. Now, I'd say that's a confusion of correlation with causation. I think every major CEO in every major US company actually plays golf. So there's a clear correlation there. So you don't need expensive management education. All you need is golf training so you can attract the best golf players. The other one I love is that if Britain wants to increase the number of Nobel Prizes it wins, aside from changing the funding model of academics and government, but don't get me onto that one, the best thing they can do is increase dark chocolate consumption, because dark chocolate consumption per head of population directly correlates with Nobel Prizes per head of population for the past 40 or 50 years. And that's a bigger data set than you see in virtually any management consultancy method set. The one which is causal, though, if you don't know it, is that attempts at suicide by drowning, peaks in that directly correlate with the release of Nicolas Cage movies, but I can sort of see a reason for that one. There's a whole website of these false correlations. Yeah? The other problem is that as we're entering conditions of extreme uncertainty post-COVID, you can't afford to define current or future practice based on what worked before COVID. It's just too dangerous because you haven't got the right sort of data. So theory-informed practice, or praxis, so I go back to the 70s, is what does the natural science tell us about what isn't possible and is possible, methods and tools consistent with that, feedback in very short time space. That's a more reliable method of method development. Yeah? And for those of you who don't know, a lot of this original work came when I was working with DARPA, when I was working directly for Admiral John Poindexter. You might remember was Reagan's national security advisor. I was working with him on counterterrorism before and after 9/11. And we were looking very specifically at weak signal detection in civilian populations. So how do you identify the early weak signals which indicate a civilian population is going to go from passive to active support of terrorism? Something we see in Northern Ireland around Bloody Sunday. And how do we measure that dispositional state so we know the level of risk we're at and we can avoid catalytic triggers to make change? So that was the work we did. That then got picked up by the Singapore government. So along with Peter Schwartz, I was one of the two principal designers on the risk assessment and horizon scanning system. And that contract funded the development of SenseMaker, which is a software tool. And then last year, I wrote the European Union handbook on how to manage complexity in a crisis. That was done with Alessandro, who was then in a design team. And that's interesting because anybody can download it for free. If you're still in the European country, they'll post it to you for free as well. But in Britain, you'll have to pay for the postage. It's the first major government publication on policy entirely based on complexity theory, without any systems thinking involved in it. And that is significant in terms of the way things are moving forward. So the second model I'm going to talk about in a second, and it's all based on the Cynefin framework, which is the first one. The second one I'm going to talk about is estro mapping, which, if anything, I'm more excited about. But I wanted to first start off by setting that context. What does the science tell us that acts as a constraint that allows us to develop new methods and tools under conditions of extreme uncertainty, because we've got that constraint, and we're trying to break away from an empirical dependence on cases, and also, to be quite honest, to really try and break that recipe book type approach which comes from it. Is, here's a recipe, follow the recipe, you get this result. And we actually know that doesn't work. So sort of cycles go around all the time. So that leads me on to Cynefin. Cynefin has been evolving for about 25, 30 years. It's now dominant framework in software development. You don't get to command level in any of the US Armed Forces without being taught Cynefin first, the same in Sweden, the same in Australia and elsewhere. Now we're starting to see that within the UK. So one of the things I'm proudest of is that about 90+% of the use doesn't involve me. Getting something which people can pick up and use is really important. But the way Cynefin works is fairly simple. At this point, I'll sort of build it in. So Cynefin works at 3 different levels. This is the sort of base level. And it identifies 3 types of system which exist in nature, again, coming back into that natural science space. Ordered systems, complex systems, and chaotic systems. I'm ignoring plasma for the moment because that's not really necessary for this. So an ordered system has a very high level of constraint, which means everything is predictable. A complex system, as I said, another definition of this, again, a Girard definition, is that a complex system has multiple entanglements. So everything is entangled with everything else. It's like the Latin Greek roots, if you don't know it, of complicated and complex. Complicated means folded, which means you can fold and unfold. Complex means entangled, and of course you can't separate something once it's got entangled. So that's a really important metaphor. And then chaos, and there's no agreement on this between different disciplines. The way I and most people in social science define chaos is a state of no effective constraints, i.e. sort of pseudo-randomness. Now, at this level, it's quite useful because I can now actually use a simple metaphor and talk about solid, liquid, and gas. So solid is my metaphor for order, liquid is my metaphor for complex, gas is my metaphor for chaotic. And as all of you will remember from high school science, there's a thing called latent heat. So you heat water up to 100 degrees, it doesn't immediately become steam until you put more heat in. My children used to laugh at me when they were young enough to laugh at me. Now they do it behind my back, probably, right? Because I used to come in and say, look, it's going to snow. I can smell it. I grew up in the country. I can smell snow coming. One of the reasons for that is heat is thrown out, in order for the liquid to become a solid to fall as snow. It always warms up slightly, and that changes the chemical balance. Now, that is called a phase shift. So in Cynefin, order, complex, and chaotic, the boundaries between them are phase shift boundaries. And the boundary between order and chaos is a catastrophic boundary. It's René Thom's catastrophe theory. I think once the pain has gone away, I can probably use examples from current British political life about what happens here. So if you over-constrain a system or you're overconfident, then actually the collapse can be catastrophic. It's the last grain of sand on the sand heap which causes it to collapse. That's Thom's catastrophe theory. So that boundary is drawn as a catastrophic fold. If you assume too much order, you're in danger of the thing collapsing catastrophically, and you won't see it till it's too late. And that also allows me to introduce the key concept of the triple point, So that's the point of the balance between temperature and pressure, where it's equiprobable whether something will effectively become solid, liquid, or gas. And in Cynefin, that's called the apparatic domain. And I'm quite proud of this. Nobody before has managed to get anything from Derrida's philosophy into the common language of American boardrooms, and I've made it. So I'm very popular in continental philosophy, and English philosophy doesn't think Derrida is a philosopher anyway, so it just carries on as normal. Aporia for Derrida is an important concept. If I ask a question to which I know an answer, it's not a question, it's a process. The only valuable questions are ones when they're asked, I have no idea how to answer it until I think differently. And that's a really important concept. And if anybody wants to go onto the open source wiki, we put all of our methods into open source. That's cynefin.io. Then you can actually see examples of physical aporia, aesthetic aporia, and linguistic aporia. Ways to change it. I did a fun one yesterday. I put up the proof of 2 = 1 on the board in a meeting I was in. If you don't know this, it's great fun. It's basic algebra, and left them for about 2 hours before I relieved them of the pain. It was causing intense agony to them in terms of the way it works. But the point is that they had to think differently about numbers and representation. Yeah, paradox is the same thing. Putting people in alien physical environments does it. There's a whole body of work on this. And the fundamental use of Cynefin at this level is kind of like starting apparatic and decide what is ordered, what is complex, and what might be chaotic. And that next level on Cynefin, it breaks down order into 2 domains. Now you see in the full Cynefin framework, clear and complicated. The dividing line here isn't a phase shift. It's kind of like ambiguous. So for example, in the UK, we drive on the left. Where I am in Germany at the moment, they drive on the right. So there's a clear relationship between cause and effect. There's total consensus about what we should do. So I can apply best practice, and the model there is sense, categorize, respond. Yeah, where am I? It's Britain. It's in the category of countries which drive on the left. I will drive on the left, and there's one right way of doing things. Yeah. Complicated is different in that there are multiple right ways of doing things. I mean, some years ago, I ended up in the Radcliffe Hospital on an emergency admission because living in thatched cottages with oak beams in Wiltshire means you occasionally crack your head. And I ended up with a 75% compression with a brain bleed. So I had the tray panning operation, 2 holes drilled in my head. I lived near Avebury, which is the New Age centres. So when they saw I was tray-panned, I couldn't resist making up stories of spiritual experience. So I've influenced the New Age culture as a result of that. But when I went into the hospital, the doctor who was going to operate on me was going to put a plastic tube into the skull, but he didn't want to do a second scan. There was then a big road traffic accident, so I got delayed for 12 hours, and the doctor who did do it just sealed everything up and took another scan. And the 2 consultants had a blazing row in front of me, ignoring me and the nurses completely. I mean, consultants are like that. It wasn't that either of them were right or wrong. That's called good practice. They both had different assessments of the risk. And one of the big mistakes we make in education and health sector is we try and force one way of doing things when people with real expertise realize that there are multiple ways. Yeah? So we get that layer of distinction. And I'm not going to go into liminality because I've only got 45 minutes, but that creates boundary conditions between the domains. So like any good framework, you can do it really simply, then you can go deeper and deeper as you get more experience. And there's actually a wonderful Cabinet Office paper on our website, which uses Cynefin to understand the role of religion in the Bush White House. And the civil servant who wrote that, who was one of the squirrels, basically phoned me up and said, "You've studied Rana, haven't you? I can see it in Cynefin." If you don't know it, Rana is the Jesuit philosopher behind Vatican II. So I was very impressed with Cabinet Office education at that point. Yeah? But if you have a search on the web, on Google Scholar or Google, you'll find lots and lots of examples of people using Cynefin. And it's a sense-making framework. It's not a model. It doesn't seek to represent reality. It basically says we need to look at things through these lenses, and we need to behave differently in different domains. So that's the key principle behind Cynefin. One of the ones I'm proudest of, this is also taught to anybody who's fire or police in the USA, to a naval postgraduate school. So somebody in a SWAT team in Tampa actually drew it with a rusty nail on the back of a breeze block in a hostage situation. They agreed it was complex, so they agreed they would probe, because if the world is complex, you have to do lots of small experiments to see what will work. Yeah, there isn't one right way of doing things. So he said it's complex, so they did probes, and actually people's lives were saved. But then they phoned up their senior command and said, it's complex, we're probing. And because Cynefin is used strategically as well as operationally, it created a language by which they both understood what was happening, and there was no need for further reference. And that ability to communicate very quickly in real time is key. So just to show you a dispositional landscape, this is coming from SenseMaker. This is also a distributed ethnographic technique. So we've done projects on citizen engagement, for example, in which we use young people as journalists to gather stories from their community. And then the human beings themselves interpret those stories. This is linked to epistemic justice, is power lies in the right to interpret. We've got a 10-year track record in the NHS now looking at patient journeys, getting patients to tell and interpret their own stories, which then informs hospital, and medical practice policy. And one of the things we can draw from that is, this is called a fitness landscape, which is a probability distribution. So this is actually looking at this sort of mass sense capability. So remember, 17% see the gorilla and 83% don't. We'll literally present a situation to say 1,000 or 500 or 50 employees or 1 million citizens. We can scale way beyond that, get them all to interpret the situation in real time. And from that, we draw these maps. Yeah, so as you can see, there's two dominant patterns, the sort of purple and the orange, and there's an outlier pattern in the red. So that actually says we can actually now make policy decisions knowing we've got resonance in the population we're working for, because we don't have to spend 6 months commissioning research, by which everything will change anyway. So this is what's described in the EU handbook as a citizen sensor network or an employee sensor network. And this is Kaufman's concept of a fitness landscape. If you want a simpler way of understanding this, this is also called the Frozen 2 strategy. So I don't know how many people have seen Frozen 2, but you've now got to go and watch it, because Professor Snowden says it's a great complexity movie, and it is. And in the middle of that movie, the real heroine of the movie, who's the young sister without magic, sings this lovely song, "All I Can Do Is the Next Right Thing," subsequently made famous by a Ukrainian refugee. In complexity, that's called the adjacent possible. And what we do with these maps is we say, this is where you are. These are the steps you can take next, which are sustainable at low energy cost. So rather than saying this is where we would like to be, you say, where are we? Where can we go next? And in complexity science, we start journeys with a sense of direction. Systems thinking has tried to define goals and close the gap. And that's a really important distinction. I know it's not universal, but it's an important distinction. So finally, I want to come in the last 10 minutes to the latest thing we've been working on. And one of the things that you can manage in a complex adaptive system are the constraints. And constraints are not just there. This isn't theory of constraints and gold rush. Constraints aren't things which are negative, some are positive. Without constraints, no evolution happens. If you have a system without constraints, all events are equiprobable, so nothing changes. So what we started to do is to do constraint mapping. And we do that using a typology. So typologies are really useful to get human beings to think through multiple lenses. So we talk about 3 types of robust constraints, and a robust constraint, well, robustness for me is something which, when it breaks catastrophically, but is very useful until it does. So we can have a rigid constraint, we can have an elastic constraint, we can have a tether. That's like a climbing rope. And when I learned to climb at the age of 10 on the Idle slabs in North Wales, I got to the top feeling proud of myself, and the climbing instructor pushed me off the top. I don't think they'd be allowed to do that anymore, but I learned the value of climbing ropes. It's something which snaps into place when you need it. We then identify resilient constraints. So these are permeable. Some things can get through, some things can't, like a salt marsh, which is more resilient than a seawall. Phase shift, that used to be difficult to explain until Roe v. Wade. Now it's really easy. There's something in the system which can suddenly produce a massive phase shift. And then the thing I'm proudest of, which is called a dark constraint, that's a reference to dark matter in physics. So I can see that there is a constraint, but I don't know what it is. So I can see an effect, but I can't see a reason for that. And we've just been doing this, multiple environments, Queensland Rail, 2 big farmers, did it yesterday with a whole bunch of German companies, doing it tomorrow. This is actually one of the most successful techniques we've produced. It's been 7 years in formation. And the other theoretical base for this is constructor theory in physics, which I'll come to in a minute. So what we basically do is either by software capture over the whole workforce or by brainstorm, we identify all the constraints that people can say. And we're doing a key thing here in terms of cognitive science. If you ask human beings to assess a situation, they can't do it objectively, no matter how well trained they are, because they have a subconscious view about what should happen. So they assess the situation based on that. So now we recognize that reality. What we do is we say, we'll map something which isn't the end point. We'll map the constraints because we can get consensus on that. And then we map them onto a grid. It's taken 7 years to make it simple. The grid goes from energy cost of change against time to change. Right? So basically what we're looking at in the constraint, if we want to alter the constraint, how much energy will it need? And that can be money or finance or whatever. How much time will it take to change? Right? Now, with the way constructor theory works in physics, this is Deutsche work, and I'll put a link into the comments later with a link to the academic paper on this. It's the first attempt in physics to try and understand the system as a whole, not in terms of its parts. So what they do in that is they identify the counterfactuals, gravity isn't going to change, and then they identify the energy gradients within the system to create predictability. There's a lot more to it than that. So once we got this up, we then draw that red line, which is called the counterfactual line. So anything upper right on that isn't going to change within the foreseeable future. It will cost too much energy, it will take too much time. And fascinating, whenever we have this, we end up with a 2 or 3 hour negotiation about what's each side of the boundary. Drawing boundaries makes people think. I mean, there I'd support Gerald Midgley on that one. Yeah. So drawing boundaries is different from saying everything has to have boundaries. Once we've done that, we then effectively identify monitors on that boundaries, things we need to look for. And we also have this concept of forward scouts. So we look at constraints further top right, and we monitor those, because if those change, it could indicate a sudden change in the system. And that, of course, creates a series of micro projects. We then draw the bottom line. So this is kind of like what's called the vulnerability line. So this identifies things which could change very quickly in very little time with no energy cost. So if any of those are high impact, and if we gather this with software, we can color code based on impact. I need to contain them quickly. That's another set of micro projects. If there are no high impact ones, I don't need to worry about it. And the zone between the two lines is known as a zone of strategic operation. So rather than say, what would I like to be? We start off by saying, what's even possible in the first place? And then we look into that space and we identify which constraints are acting as boundary conditions, either passive, things bounce off them, or some things can pass through, and which are acting as what are called constructors. So a constructor is something which produces a replicable outcome, like a machine, or also in human beings, things like a ritual or a process. And having identified that, we go through them and say, which do we want to keep, which do we want to amend, which do we want to destroy? Another set of micro projects. And then we use safe to fail experiments to generate constructors where we need them. And remember that the modulators and the magnets, what I'm doing is I'm gaining control of many things as I control about, as I can control, which means I know the energy gradients of change within the system, which gives me better predictive and intervention capacity. We're now doing this in military decision-making on red-blue teaming. So we effectively do our perspective, the enemy's perspective, we look at the two, or senior management employees. So seeing things from different perspectives is a key complexity technique. And they say the goal on here, and this is fractal, so I can have this for a country level, a department level, a regional level, a company level, a hospital ward. Everybody is working at the level of their competence to act. And what you're doing, this is a key complexity principle, is you're changing the dispositional state so that the things you want are more likely to happen and will consume less energy. And reduction of energy consumption is key in evolution, and it's key in policy, whether in a company or a government. So this is kind of like the first time This has been mapped, and this is the extension of the EU field guide. There's a whole facilitation kit we finished on this. And it's got a lot of interest now in the foresight community, because this gives us a complete alternative to scenario planning. And it's also real time. And the reason we called it the S-Strime model is to use that as a metaphor, partly as a contradiction with constructional law, which is different. That comes from thermodynamics. So in an estuary, which is not the same thing as a delta, in a delta, the water flows into the sea. In an estuary, the tide comes back up into the ridge mouth. So the water flows in two directions. And there are things you can do at the turn of the tide that you can't do when the water is flowing. There are granite cliffs, which you only have to survey every 50 years. There are sandbanks you have to check every day. And then you have to make investment decisions about, do I dredge a channel or do I rely on local guides? So this concept of seeing strategy in the zone of strategic operation as an ecological system, not a mechanical system, not an engineered system, with inherent uncertainty, but critically with the ability to manage it. And I'll finish off two things really. One is, you'll also notice what I'm doing is not generating one massive program. I'm generating lots and lots of highly specific micro programs, some of which will fail, some of which will succeed, which will change the space I'm operating in. So that's a massive risk reduction in terms of government or industrial policy, because lots and lots of small projects gives me more recovery time. I can sort of steer the ship, if you want to take that as a metaphor. And then the final thing, I just want to go, one of the things I've been arguing for a long time, a lot of people use complexity as a metaphor. It isn't a metaphor. It's called real science. If you're watching, neo-materialism is worth reading up on. But fundamentally, it can be managed. A lot of people use it's complex, so I can't be expected to do anything. That's actually wrong. So I want to go back to the origin of the word manage in English, and I'm not going to risk because my Italian is not good enough. But the origin of the word manage in English is an Italian word, which means the ability to ride a horse in dressage. It then gets corrupted by the French to mean household management. Yeah, so what you've actually got is manage and menage. So in a complex system, I'm riding a horse. In an ordered system, I'm managing a household budget. And understanding where you are and what you do is critical. In an ordered system, I can use all of the classic systems thinking approach. Where do I want to be? How do I close the gap? What do I need people to do? That's fine. The minute it becomes complex, that is the worst possible thing to do. You need to map the present and identify what pathways are open to you with very fast feedback loops. Because if I start a journey with a sense of direction, I'm open to novelty and new discoveries on the pathway, which kind of like is sort of the really final point. The other big area we're working on here for government policy is what is called a vector measure, because outcome measures produce perverse incentives. Vector measures measure precisely that. From where I am I going in the right direction, the right speed for right energy consumption? And if you don't know it, I can give you the reference on this. Whenever people are working for explicit goals, it destroys intrinsic motivation. There's no evidence to contradict that. And where do we have the highest level of explicit goals? Health, education, social services. Where do we most need intrinsic motivation? Health, the same three. But we still got to measure it. This is important. So what we can do in complexity is we can measure the current dispositional state. We can identify a direction of travel, and we can set you a KPI to achieve that direction of travel. And that's non-gameable. So there's a whole body of practical tools and methods on this, but critically, it's a natural science approach to understanding human systems. And in some circles, we call it anthro-complexity, to contrast with computational complexity, which is more the agent-based modeling simulation we'll find with Cynefin. So I went 1 minute over, Brian, but that's kind of like it.
It's impressive. Thank you, David. Yeah, I mean, to me, that's, that what I really appreciated about the presentation, and we've got a bunch of questions here that I'll go to, is this idea of actually thinking through what's happening. And I think a lot of complexity methods have that sort of sense of removal from the very thing you're studying, and then trying to sort of treat it as this,
Sorry, I'm on a call. Yeah.
This object.
I'm telling Bill in, so that was housekeeping.
no worries, as an object of study, as opposed to actually providing effective ways of actually thinking through the act of evaluation, for example, with the work that my colleagues and I do, and then really taking time to actually, rather than just saying, oh, everything's complex, to actually say, what is this system that's in front of me? And then thinking about that aspect of how that helps you decide where to put your focus. And I really appreciate that. If we can go to some of the questions. So the first question is from Mati. Magnets and other physical systems can be controlled by manipulating control parameters. What are the equivalents of control parameters in human systems in your view?
I mean, men varies. I mean, you've got the fairly obvious thing about incentives, yeah. But actually, I think one of the key things which comes out of complexity, and this will partly answer the second question, but I'll go on to that, is that how things connect matter much more than what they are. Yeah, and actually that means, so it's ethical to change how people connect with each other, but I'm not sure it's ethical to try and change how they think. So changing people's social dynamics. So I'll give you an example. One of the projects we're currently working on is we're putting people from commercial R&D and pure science together in groups of three people. And those three people are working together in mass parallel projects to identify what's possible. And do the same I'm giving a lecture at, I'm just taking a position at the Carter School at George Washington on peace and reconciliation. So we're doing the same thing there. We're putting people from radically different political backgrounds together in very small groups and getting them to work on problems which are nothing to do with their differences. Yeah, and then they start to discover they've got more in common than they realized, and they can have a conversation in their own time. So changing people's linkages are one of the things which is one of the most effective types of change. The other one, and that map I showed you earlier, the fitness landscape, we use that to measure attitudes. So, and this links into this new theory of change. I can look at an attitudinal map, and we've done it for culture, for safety, for cybersecurity. I was working with GCHQ, right? Basically, we can measure attitudes, which are lead indicators, whereas compliance is a lag indicator. You can look on those maps and you can literally click on it and say, how can I create more observations like these and fewer observations like those? So if I look in a hospital, if you go to nurses and say, how do I create a better attitude for patient empathy and care, they'll get defensive. If you gather patient stories for the last 6 months and you can say, I need more patient stories like these and fewer like those, you can engage people at all levels and they'll do something. So there's a whole series of things that you can manage on that. That really leads me on to Thea's project. And I'm sorry to confuse you, Thea, but the problem is that actually most of the decisions are made for you by your body or by your social interactions. When you pull your hand away from a hot plate, your brain isn't consciously doing it. Yeah. It fires after the event, and that doesn't mean you haven't got free will. It's firing after the event to check if the autonomic response was right this time. There are nerves in your gut, your body, and this is post-Cartesian, right? The other big thing is the stories. This is assemblage theory and Deleuzian epistemology, right? Fundamentally, the stories which are part of the society you grew up with, either at a national level or a micro level, effectively create like an attractor well, and you can only filter data through those stories. So it's not in your brain. Your brain is a very small part of your decision making. It's a distributed framework. So talking about mental models or mindsets sets people into this cognitive way of thinking, which is a Descartesian Cartesian solution, which is actually the worst way of thinking about it. So we do a lot of work distributed decision making. So the trios is a good one. You can actually say if 3 people from different backgrounds and different divisions make a decision, it's authorized. It's transparent, it's visible. You don't delegate because then people get nervous about are they doing what the person who delegates the power to them wants. But you can distribute decision making, and again, that's by changing interactions, right? And if people are physically together from radically different backgrounds, there's better energy, or they're more likely to do things. So we are social beings. We're not atomistic brains. It's why the whole concept of the singularity is nonsense, because you can't, if you want to build a container for the brain, you've got to evolve a body. So it's the same thing, right? Anybody who really believes in the singularity, their brain is probably ossified to the point where for them it would be possible, right? We're social creatures, we're embodied creatures, we're enacted creatures. And therefore, we need to look at the complexity of the whole of the environment in which we're making decisions, not try and say it's all down to something in our brain. Yeah.
And it reminds me of the article by Richard Rorty talking about Rawls' theory of justice versus telling people stories and getting people together who are different. That changes people's minds quicker than reading anything on justice. So
we did it in Northern Ireland back in the 70s. And I wrote a blog post on this recently. So I was then a Jesuit in training, right? And we had the Coromila approach, which is get everybody together in a big hall and talk about how we should be nice to each other, which was wonderfully satirized in episode 1 of series 2 of Derry Girls, in which the Catholic girls are forced into a peace and reconciliation process with the Protestant boys led by a trendy priest, watched over by a cynical nun. If you ever want to see satire, that is just brilliant, that bit. We took people from both communities and we dumped them into Latin America for 6 months. And they discovered pretty fast they had more in common than they realized. There's actually a great film called The Journey, which is a semi-fictional story of MI5 manipulating Paisley, to be in the same place as McGuinness. So they had to work out what they had in common so that they can actually move into Good Friday. So that's actually a key process. And we do that now extensively in companies, bringing people together in groups of less than 5 to work on programs in parallel. Another good example on that is the software development stuff we're doing. So instead of sending a systems analyst out to interview people and inattentional blindness, they would only listen to what they think they expect to hear. And just to really scare some of you, if you do more than 2 interviews, you form a subconscious hypothesis and you only pay attention to things that match that hypothesis thereafter. You can't avoid that. It's what it is to be human. So we put together a young, bright programmer with a systems architect, young and old, together with user trained to talk to IT people. It's easier to train users to talk to IT people than train IT people to understand users. And we basically throw 15 trios at a problem part-time for 3 weeks and then see what they come up with, and that goes into a requirement. The citizen engagement stuff we've done is young person with person from their grandparents' generation in a trio with somebody from local government who can make their ideas work. So you generate hundreds of micro interventions at a community level rather than some massive government program. There's an awful lot we can do with this, which reduces the energy cost of effective change.
yeah, and so to move from that, David, the next question is on patterns arising from self-quantified narratives. What are they data of? What is the state space described by narratives? Would you call them measurements reflecting the macro state of a system, for example?
Okay, so I need to explain how we do it. So I'll give my standard illustration, right? If you've ever filled out an employee satisfaction survey, and we have these all the time in IBM, all right, and you get it and say, does your manager consult you on a regular basis, scale of 0, not at all, 10 all the time? Yeah. And what you would then do is you know exactly what answer they want. So if you're in a good mood, you give it 10. If you're in a bad mood, you give it 0. If you're statistically literate, you make it 8 or 2 because you know they're going to eliminate outliers anyway, right? So the evidence is you gift or you game. So we take a different approach. We ask a non-hypothesis question. So what story would you tell your best friend if they were offered a job in your workplace? Then we ask people to interpret that story, and we might have, for example, 6 triangles. There's all sorts of scientific reasons for this, all right, which I'll go into if people want. One of the triangles says, in this story, the manager's behavior was altruistic, assertive, analytical. So 3 positive qualities. So the respondent doesn't know what the right answer is. That creates a trigger from what Kahneman called thinking slow, fast, thinking slow. But if you increase cognitive load, people go deeper. So with 6 triangles, I've got 18 data points, and critically, the person who told the story has interpreted it. And it's not the same as sentiment analysis or AI, because what happens is they add layers of meaning to the story. They just interrupt it. And it allows us to capture voice and picture as well as text. What you can write down is about 5 or 6% of what you know. So that's called high abstraction metadata. That was developed with the US government, is patented. It's a key aspect because abstraction, art, if you don't know it, I'm jumping around a bit, but art comes before language in human evolution. And we think the reason for it is abstraction allows us to see novel connections. Yeah, if we stay in the concrete, we don't. So we're taking the same principle, move up a level of abstraction, you actually get better meaning and more novel connections that come out of it. So the fitness landscapes are basically probability distributions done using that material, but I always know where the stories are. So I've got the objectivity of numbers together with the explanatory power of narrative. So those two go together in that way. Yeah.
Yeah, so the next question is, could you clarify how the discrete Cynefin system types relate to what you said earlier about systems not having well-behaved borders? And that is something I was interested in as well. Seems like every system has sub-elements all the way down. So is it turtles all the way down?
Yeah, I mean, it's saying that some systems don't have borders doesn't mean that all systems don't have borders. Yeah, I mean, the issue is to challenge that, all right? So a complex system generally doesn't, an ordered system does, and we can actually have ordered systems and intersecting ordered systems within a complex system. And that's where we get into fractality of representation. So at one fractal level, it may actually be ordered. At the next level, it may actually be complex. And that's why getting this human metadata in significant numbers is kind of like really important, yeah? The other thing I often say about the Cynefin framework is, and if people haven't read up on neo-materialism yet, it's worth reading up in terms of philosophy, because it basically, this is Delander and others, it basically says, you know, modernism and postmodernism, social constructivism, critical realism are kind of like irrelevant anymore. We now understand the way that human attitudes have physical reality. And so coming from a neo-materialist perspective on this, we can say, look, we have reality ontology. We have the way we know things, epistemology, and that's collective in many cases for humans. And then we have phenomenology, how people perceive things. And by the way, this is another big distinction between complexity thinking and systems thinking. Systems thinking says the nature of the system is in the eye of the beholder. Complexity thinking says, sorry, yeah, it's a part of it, but actually systems can be complex independently of being seen. Yeah, there is a tree around in the quad, even if I'm not there to perceive it, to go back to my philosophy. Right? So one of the key things we focus on is how do we increase the friction between how things are, how we know them, and how we perceive them. So for example, if we create a situational assessment and we give it to the whole of a workforce, I can then show how management is seeing it, about how workers from different backgrounds are seeing it. And I can say, why do we think that's different? Yeah. So rather than tell managers they're not connected with the workforce, we said, you interpret it like this, they interpret it like that. Why do you think you've got a difference? That increases that friction. Yeah. And in all cases, you're trying to get this, remember my definition of sense making. You're trying to get to the point where you know enough about what you know so that you can take an appropriate action.
Yeah, makes good sense. Unfortunately, we're out of time. There were two last questions. Hannah asked about tools for recommending, and Elliot asked about the ethical dimensions. I know we're out of time. Is there any quick 30-second response to each?
If you go onto our website, there's plenty of stuff about the tools and methods. I say the methods are open source. If you look up SenseMaker, you'll see loads of case studies in health and citizen engagement. Yeah, and the Cynefin Center is a not-for-profit arm of what we do, which is that sector. I mean, there's an ethical aspect to anything in a human system, yeah? But there's an interesting difference between rules and heuristics. Yeah, in a complex system, you're generally operating off heuristics, not rules, and rules can create catastrophic failure. So I think there's a whole body of stuff on that. And remember, I studied aesthetics and ethics at university. So if you get me off onto this, I'll carry on for ages. But yes, it's a significant factor.
Okay, brilliant. Absolutely wonderful. Thank you so much, David, for your presentation today. And on behalf of CECAN, thanks to everybody that came today and attended. And we wish you all best rest of the day.
Thanks.
Take care, everybody.